Kia ora and welcome to video 18 in the series Insightful Integration. This problem here, we're going to look at another unfamiliar integral, an application here involving the centre of mass of a shape. I have seen this in an excellence question in NCEA integration, but this is slightly different because we've got two curves. We've got an upper curve and a lower curve, and we're only given the formulas to find the centroid of the centroid of a shape involving one curve f of x. So you do need to think about how you'll adapt those equations for this region. That is the tricky part of this overall problem. Anyways, all the best with that, and we'll catch you for the solution shortly. Okay, so if you're interested in the derivation of these formulas, search up finding the centroid of a shape using integration, and there is some explanation around it. It's kind of related to physics, but that's not what we need to do in the middle of an exam, right? We see a formula, we just need to know how do we use the formula. The tricky part of this is knowing what to do with the fact that we've got two functions. Okay, so we've got an f of x here, and I initially thought, hey, let's just make f of x equal to the difference between two functions, like we do when we're trying to find the area between two curves. So the top function is square root x and the bottom function is x cubed. Now it turns out it works for the x coordinate because of how integrals work. The integral of a difference is the same as the difference of integrals, so it does work. But it doesn't work in the y value because we're squaring the f of x. And f of x, if it's the difference between two functions, we know that a minus b squared doesn't equal a squared minus b squared, although some of my juniors do think it does. So I originally made f of x the difference between the two functions and found it didn't work. And I knew because the y coordinate came out not to match the picture. It was too high, too low. It might have even been outside the shape, I can't remember, but that enabled me to reflect and go, I've got something wrong here, and I switched it. So to find the x coordinate, it's pretty straightforward. As I was saying, we've got 1 over the area of the function, the area of the shape, which is a separate integral in itself. We're integrating between 0 and 1, x multiplied by f of x, and like I said, for this one we can actually just write square root x minus x cubed. And then the area, which we're going to use in both x and y, is the integral between 0 and 1 of the top function minus the bottom function. So let's do that first. X to the half goes to x to the 3 over 2 divided by 3 over 2. That one's x to the 4 over 4 between 1 and 0. So if we work that one out first, we've got 2/3 minus 1/4, which is 5/12. And then we put that into the 1 over a part of the formula, so 12/5 integral between 0 and 1. X times root x is x to the 3 over 2 minus x cubed times x to the 4. That's x to the 5 over 2 times 2/5 minus x to the 5 over 5 between 1 and 0. And then we sub in that, 2/5 minus 1/5 is 1/5 times 12 over 5 gives you 0.48. And that does match up with the picture, 0.48, just a little bit less than 0.5. Okay, for the y value, we've got 1 over 2a, integral 0 to 1. We don't have that x factor in the front, but we've got f of x all squared. The 2 came in there with the 2a. So f of x all squared, well, we want the square root of x all squared, then we minus off the x cubed bit all squared. And that's how you solve this problem when you've got two functions. Now, I wasn't to know that, honestly. I tried it as the difference between two functions and just got a wrong answer, and then tried it this way, and it worked. And sometimes when you get an unfamiliar integral, you just have to reflect on your answer and then try a different way. Okay, so this one here, integrating between 0 and 1, the area is still 5/12, so we've got 1 over 2 lots of that, 12 over 10. And then we're integrating x minus x to the 6. Inconsistent with brackets, really should be brackets around all of that when we're integrating. X squared over 2 minus x to the 7 over 7. And we have a half minus a seventh times 1.2. And that gives us 3/7, or 0.442, so 429, 3 decimal places. Does that match the graph? Looks like it does. Alrighty, not bad. The problem wasn't too bad. It just is a little bit different. They gave you some formulas and they weren't quite ready to use. We had to think about them. But hopefully you enjoyed that. And like I said, if you're interested in where those formulas came from and you do a bit of physics, I recommend you look it up on YouTube.